title is Compaction and its Effect on Early and Late Season Root Lodging in Corn. So to start off a little bit about myself, I did grow up on a 1,200 acre corn and soybean farm in east central Illinois. My dad and my brother currently operate the farm. Like Dr. Cruz just said, I've been in agriculture my entire life. I just recently got married to my wife Leah on June 28th, and on Friday we're leaving for our honeymoon. So getting this wrapped up and then going on.
Can we ask where you're going?
We're going to Costa Rica.
Oh, awesome.
Yeah, so 9 days, we're looking forward to it. A little bit about my career and my education. I did my undergraduate at Illinois State University, graduated there in 2008 with a double major in ag business and agronomy. After that, I went on to corn research. I started at AgriLiant Genetics in 2008, shortly after graduation. There I was a yield trial manager, was in charge of all planting operations, harvest operations. I made sure that all the notes were getting taken and that kind of stuff for all of our outlying locations. In 2011, I moved to DuPont Pioneer in Princeton, Illinois, where I currently reside. There I work again on the yield trial side of things, where I'm in charge of a lot of the planting, harvest operations. I deal with all of our cooperators, so we've got 16 different cooperators across northern Illinois, so I deal with them primarily. And then I did start the master's program here August of 2011. So shortly after I started at Pioneer, I started this program. So a little bit about compaction in general. Compaction is a long-standing issue that we have that continues to affect the industry. With fewer farmers and larger, more and more acres that they're farming, the timing of it is really just, it's not kosher. So we get guys that are dealing with putting in their large equipment in poor timing. You know, the ground's really extremely wet when they shouldn't be in there. They're doing harvest operations during that time frame. They're doing tillage operations that time frame, which is just causing more and more issues. So repeated traffic passes also cause some issues. And then animals can also cause some issues. There's not so much of that in my area because animals just aren't predominant, but you know, some of the areas where it's more hilly, the animals are causing some serious compaction issues. So compaction occurs when soil particles are pushed together. The picture on the right shows a depiction of compacted soil versus non-compacted. As you can see on the right-hand side, the non-compacted has a lot more air particles, allows for more soil penetration, more water movement, and allows for root growth to really expand into the soil profile. The one on the left shows it really compacted in together, doesn't allow for all that water or air or root growth to really penetrate down through. So a little bit on my project now. Project started with a proprietary root assay that we have at our location across, and as well as across some of our other locations across northern Illinois or northern America. We evaluate the hybrids in a controlled environment. So we're looking at the genetics of our hybrids as well as the environmental issues. So the big thing that we saw is that we have weed pressure that we can't really control necessarily just on the pre-herbicide application. We wanted to know if we could go in there with a post and not really mess with the root growth and the data that we were getting off of that. So that's what kind of enticed this project. And then, so I went ahead and I did the compaction treatments in extreme conditions. We did it in extremely wet conditions instead of the typical sprayer gush going through it on a dry soil condition like you typically would. We did that just to really get some good sidewall compaction to see if that was going to affect anything. So main objectives was to investigate those effects and determine the ability for the sprayer to go through without adversely affecting our results. So we'll go into some materials and methods. The experiment was conducted in 2 different years, both 2013 and 2014. We used 6 different hybrids, both years the same hybrids. They were ranged from 108 to 111 relative maturity. 3 of them were known to be susceptible to root lodging, and the other 3 were above average ability to withstand root lodging. So that's based off of years and years of testing. These are commercial hybrids that we know from previous years on how well they perform. Both years had 4 treatments. The 2013 one had a control, the tractor, the sprayer empty, and the sprayer full. I'll go into these in the next couple slides. And then the 2014 had a control and then all sprayer applications, but we went ahead and did one in dry conditions just to see how well it performed in the conditions that we would be actually performing it in. And then we did it in the wet and wet application, both empty and full, just to kind of replicate the 2013 data. So the field prep, conventional tillage, went fall application with a ripper 10 inches deep, spring application right before the planter with a field cultivator at 4 inches deep. The soil type was a stable silty clay loam, 0 to 2% slope. Pattern tiled on every 40-foot centers. And then the field planting was in a 4-row plots, so 30-inch rows, 350,000 seed, or 35,000, sorry, seeds per acre. And then the data collected was just in the 2 rows, 2 middle rows. So treatments for 2013 were conducted after 1.5 inches of rain at V2 growth stage. The control had no additional passes after planting, so the planter went through, and then after that there was no additional passes whatsoever. Then we came through, second treatment was the John Deere 6140R. It has a widened wheelbase. We do that at our location for compaction purposes while we're planting. So that actually has the same widened wheelbase as what a typical sprayer would have. So that's why I was able to use this tractor as well as the sprayer, because it all had the same wheelbase. So then I used the Hagie STS-10 sprayer empty, and then I filled it up with 1,000 gallons of water. So on the far right hand side you see the weights of those particular implements. So in 2014, again, I had the control with no additional tractor passes. I had the dry application with the sprayer, and then I had the wet applications afterwards. We did the dry and wet. They were calling for like 2 inches of rain that night, so we went ahead and did the dry application the night before. It rained. We did the wet applications afterwards. As you can see, we only had 1/2 inch of rain. We didn't get the 2 inches that they were calling for, but we had to go ahead and go with it so that the compaction treatments were on the same time frame. So on the far right hand side again, you see the weights. So our field setup. First thing we do, we lay out our lay flat all the way around the field. That's the blue right underneath the tractor, that's the lay flat. We have a well that's specifically for this purpose. This entire field is operated off of one well. It's got underground irrigation system into it, so there's risers on either end of the field. We have a closed circuit within our lay flat, so the front side and the back side are connected into the risers, and they loop in. We put like a driveway through the middle so that everything can loop in together. That way we make sure that we have a consistent flow of water throughout the entire field. We then go ahead and we pull the drip tape through the field. We hire on 8 kids to help us pull that through. We have a tractor set up just like this on one side and a tractor set up just like that on the other side, and the kids go at the same time. They just keep crisscrossing around. When they get there, we'll cut it off, hook it up into the lay flat, and they can go on. The drip tape itself is a John Deere drip tape. It's got emitters over 8 inches. It's got 0.67 gallons per minute per 100-foot water capacity. After that, we go ahead and we push the drip. Well, when they're pulling it through, it goes down the middle of the row just for ease of plant growth, and it's not really important at that point. But when it comes down to starting to water for our simulated wind event that we're going to do for this study, we fire up the well and we push all the water or all the drip tape over up against the rows so that the water is concentrated just on the rows that we are going to end up blowing through. So we do that 1 week ahead of time. So we want to make sure that we get all of that completely through, or the water completely running through everything, and get the ground completely saturated before we actually do the simulated wind blow. So the wind event itself, the wind machine is a modified Hagie sprayer with blowers on the front. As you can see in the picture, there's 2 engines that run the 2 big fans all into a concentrated area. So when that's actually going through the field, it's concentrating wind on just the 2 rows that it's aiming at. The other wind is not affecting any of the other rows around it. We can set the desired RPMs for the fan speed. We do that based off of a calibration strip. The calibration strip actually has the same hybrids that I use for the compaction study. 3 of them, again, are known to be susceptible to root lodging. The other 3 are known to be good standability. So we go through and we set an RPMs based off of the year previous. We go through and see if everything is standing like it should be or falling over like it should be. If it's not, then we adjust the RPMs to make sure that everything is actually done consistently. And then we go ahead and we go through the entire rest of the field and take our data off of that. This is meant to simulate a typical thunderstorm. So we do all the irrigation to get a good torrential downpour going on. And then we can, increase our wind speeds as high as 60 to 70 mile an hour. But we don't have a way of actually measuring the miles per hour, so we just go off of RPMs. So the wind machine blows 1 row of data per plot. So the picture on the right kind of goes into a little bit of detail on kind of how this all works. The top column is the plots 1 and 2, and then within each plot you've got 4 different rows. So the hash lines are each range worth of data plots, and then the solid red line is where the tractor tires would actually be going. So within each treatment there is 1 tractor pass, or 1 tire I guess, per plot. And then on the far bottom you can see that we blow the early rows on rows 1 and 2, and then we come back after and blow the late rows in 3 and 4, but only take data in row 2 for the early and row 3 in the late. So the first simulated wind blow is conducted in late June, right before braced root development. We try and get it, it's usually between 900 and 1100 heat units. And then we come in again with the second simulated blow conducted shortly after pollination. Then the RPMs are increased because of the braced root development. So the braced roots obviously help keep that plant staying a little bit better. So we increase that wind speed just to try and make sure that we still get a good bell curve going on when we're looking at our data. So I had a natural wind event. In 2014, we were going to do the simulated wind event. Didn't happen because we had a huge thunderstorm came through. Happened 3 days before we were actually going to conduct the simulated wind blow. So we had actually already started watering. So it actually already was pretty much saturated, and then we got another close to 2 inches of rain on top of that. So the ground was completely saturated, and then we got wind gusts as high as 36 mile an hour. So we went ahead and we took the data on that one, but then the second simulated didn't happen because the rows were all tangled up still from the first one. We weren't going to get any valid data off of it. So the experimental designs. In 2013, I used a completely randomized split block design. Probability level of 0.05 was used to determine the treatment significance. Here's a field layout of kind of how that looked. The yellow is the control, the blue is the tractor, the red's the Higgy empty, and the green's the Higgy full. So you can see on the bottom, well, each one of those little squares there is 2 rows, and so there's 8 rows total per treatment. In 2014, I changed it up a little bit. I went with a RCBD design with nesting groups, and probability level again was at 0.05. Here's the field layout of that. The difference here is that you can see that gray area there in the middle. That was for turning around ability of the equipment. So as you can see, the blue is the empty dry, the green is control, orange is empty wet, and the red is full wet. But we didn't want to have the column effect that we were seeing in 2013, so we went ahead and took the equipment up on one side, jockeyed it around in the middle, and then went up another pass to take away some of our column effect that we had. So some data collection methods that we used. We took stand counts, took those all about V2, V3. Then we took plot scores. So plot score is a subjective score that is given to determine the quality of the plots. The scores are ranked from 1 to 9, 1 being poor, 9 being excellent. We use these for data analysis later on to see how well that plot was performing early on, to see if we can really evaluate that data later on in the season and not really affect our overall results. In 2013, I took plant heights. Took these right before the simulated wind event, usually a day before. So the early one was taken The average of the plot was the extension of the ear leaf, or of the upper leaf that was in that plot. And then we took the second one from the tip of the tassel, since it was after pollination, the tassels were emerged. Then we took root lodging counts. The crew counted the number of plants that are lodged after the wind event. So go through with the machine, crews come in right behind us, and they count it. So they count that on anything that's 30 degrees past vertical. They know this by, we have little handheld devices that's got a little, or just handheld, you know, and they got a 30-degree angle on the bottom of it. On the handle, it's got a level that tells them that, all right, we're level with the ground, so anything past 30 degrees, they count. Anything above 30 degrees, they don't count it. Counts are then calculated as a percent not lodged based off the original stand counts. So we use that just for data analysis purposes. So the data analysis I used was a proc mix type 3 ANOVA procedure in SAS. The LS mean was analyzed and then converted to letter groupings using the DP mix 800 macro. The fixed effects were treatment, hybrid, and hybrid by treatment interaction, and then I added in a random effect of rep in the 2014 data. So going into some results. The results, I have the early root lodging for both 2013 and 2014. And then just for 2013, I have early plant height, late root lodging, and late plant height. So with the early simulated root lodging, we've got treatment and hybrid terms both statistically significant. You can see that from the p-value on the far right-hand side. We expect hybrid to be significant because of the differences in those 6 hybrids. You know, since they're so different, we expect that to be. The LS means, the tractor pass and the full sprayer pass are both statistically different from the empty sprayer. You can tell that from the B's versus the A's. The early plant height, again, the treatment and the hybrid are both statistically significant, which is similar to the early root lodging. What the LS means on the plant height, early plant height, the control and the full sprayer are statistically different from the tractor and the empty sprayer. The late simulated root lodging, treatments, hybrids, and hybrid by treatment interaction are all statistically significant. The hybrid and treatment interaction is shown, you know, we're getting a different rank in the hybrids, so that's maybe telling us that there could be some field variation going on. The late simulated root lodging, the LS means for this, all 3 treatments were statistically different from the control. And then the late plant height hybrid is the only term that is statistically significant. Now for the 2014 results, the early natural root lodging, treatment, hybrid, and rep are all statistically significant. Rep could be statistically significant because of the differences in the wind pattern. We can't guarantee that the wind was completely blown exactly the same. We all know how wind swirls. So the calibration strip for that year did show that we were getting a good spread, but across the field it might have changed up a little bit. So that could be the reason for replication being different, or significant, I mean. And then the sprayer in dry conditions was statistically different from the control. So our overall 2013 conclusions. Running equipment through the field after planting does have an effect on the root assay project. The experimental design could have played a factor in the role because we didn't really know if the treatment and the column effects, they were confounded, so we really didn't know which one was the significant part of that. So we decided to run the experiment again with a different experimental design. So in 2014, the better experimental design allowed for, you know, the differentiation between the treatments versus columns. The treatment of applications of both the dry and the wet helped to get a full perspective of how the compaction really affected the roots. We weren't just making everything wet and making sure that, you know, we weren't putting in extreme conditions. We were actually seeing what we were really after on whether we can actually spray that field during the growing season. And then the natural winds were collected instead of the simulated winds, and that could have played a factor in our results. So our overall conclusions was that running the equipment does have an effect on the root assay project, and that post-planting equipment passes will not be recommended for the future experiments, not only across our locations, but across all of the North America locations. This was kind of sponsored by one of our other, the guy that's in charge of that, and he's on board with not having this go. So some acknowledgments. I'd like to thank Dr. Cruz for helping me out through all this. He was very prompt on all the questions I asked, so I'd like to thank him. I'd like to thank the Pioneer staff. These guys all helped me out with, the layout of all this stuff as far as the data collection and getting the field set up. And then Deanne Wright helped me with the early on stats from Pioneer. And then, of course, my wife, Leah. She has been my rock. She has not let me quit. She's pushed me harder and harder, so definitely want to thank her. So this time, I'd like to thank everybody for taking time out of your day, and I'll entertain any questions that you might have.
I have some general questions. I thank you for explaining your definition of root lodging, the 30 degrees. So how does that differ from stock lodging? And did you see both in your experiment?
It differs from stock lodging because stock lodging is later season. Stock lodging typically is after the ear development, and stock lodging will usually happen below the ear. We did have brittle snap. Brittle snap is something that we'll see this early season stuff. We just seen quite a bit of that. Some of these that were actually had good roots actually had brittle issues, but that wasn't what we were looking for. We were looking just for the roots. So, that answer your question?
Yep, it does. Okay. And did you see a lot of difference between your? I think your wind machine was really cool. So, and you mentioned that when you've been in the natural thunderstorm, that your rows were all tangled and everything. So, yep. Did you see a difference between your simulated and your natural? It's just the way your plots ended.
Not.
Were they just as tangled with the normal wind machine as they were with the thunderstorm?
For the most part, yes. And that's kind of why we went ahead and took the data. If the whole field would have been flat, we would have said, it's just a wash. There's no point in doing this. But we went into our calibration strip. Like I said, it was the same hybrids that we used for my compaction study, and the good ones were standing well, and the bad ones were flat. So we said, all right, yeah, we can go ahead and take the data off of this. So it was where it needed to be. Dr. Chia?
When did you take your 30-degree angle right after?
It was right after the machine went through. So the machine went through. We let it get past probably 2 passes because the machine's extremely noisy. And then they went ahead and they went and counted it. So would
the plants regrow back up?
Not that quick, no.
No, not
Yes, they would. That's why we do it right away. Sorry. Yeah. Yes, they would grow. They'd start to gooseneck back up. So we want to make sure that we get the actual data that in the time frame that we do it. We can do it probably 2 days afterwards, and we probably wouldn't have much of a gooseneck. But we like to just get it right away, just in case we got a big torrential rain pour and it affected. If that night we got a big thunderstorm and it pushed over more plants, then we really wouldn't be getting a fair representation.
I was curious if you went back in and looked at, a month later to see if you had differences in your hybrids with regard to going back.
Could have. We didn't do that.
Yeah. And you mentioned that you had, you call it brittle snap, green snap, whatever you want to call it.
Yep.
So you did have some variety effects there.
We did. Yep.
This is your opportunity. Leah, you've been pushing. It's time to kick one more time.
Yep.
The machines, like the Haggy was 30,000 pounds. What was the actual footprint? Do you know, in pounds?
I do. I actually have that in my paper. I didn't write it down in this, and I don't have that necessarily right off my head, but the Hagee itself is supposed to have not a heavy compaction issue across. Hagee likes to market their stuff as being a low footprint. The tractor was a little bit wider wheelbase, so it would have had a little bit more of a footprint, which is also another reason why we went ahead and just did the sprayer in 2014. But I don't know the actual footprint of what it would have been.
That's a good question. What's the tire pressure?
That's in that. paper too, sorry.
Another question with regard to, you say that the company's not going to use that print across or not do a post application.
Yep.
Now, the question comes up with regard, is that going to give the farmers some hybrids in the future that won't stand up as well? Because they're going to have to come in and spray post application.
Right. This is just for the simulated aspect of it. I mean, you're obviously going to have that in a natural environment. We're just trying to, by not having that go through there, we're making sure that everything is treated equally. We're dealing with plots. We're not dealing with overall conventional farming. So we really just trying to make sure that what we're doing in these plots is treated equally across everything. And as you saw in the control was different than what everything else was doing. So we want to just make sure that we're getting consistency across everything. Because, this is a 40-acre field that we're dealing with outside of my experiment. The whole field itself is a 40-acre field. So we only have sprayer tracks every, 20 plots or so. Those are getting treated differently than the ones that don't have that sprayer pass. So that's why we're kind of saying, let's just not do it. That way we get everything treated exactly the same. So we've talked about possibly doing aerial spraying instead, or finding different means of herbicide application if need be on this location so we don't have that issue. Yes?
Kind of to his question, you looked at the LS means in some of your tables. The control was not always like the worst or the best. So what kind of can you speculate to say why maybe the plots that were subjected to the root lodging treatments maybe performed better than the control, which is
You got a honeymoon coming. 9 days after you work.
Yeah. Can you ask that again? I'm sorry.
Well, I was what you speculated on why maybe the treatments, the treatments with the compaction actually had less root lodging on the ones that the control. And possibly having to do with like the soil structure.
Yeah, I guess I really don't have a good answer for that. Sorry.
I mean, that would just lead me to believe that maybe we have tilled the structure of the soil and that a little compaction actually helped in this case.
Yeah, we were seeing that. Definitely something that we were seeing is that, by putting in that extra compaction, maybe that was helping the root structure for whatever reason. So we might have seen that, there was some issues going on with just the tillage that we were doing or just the overall structure of the soil.
Following up on that, your compaction occurred after the crop was grown.
Right.
What would happen if that compaction was there from maybe combine harvest the fall before or something prior to early season?
Right. I'm sure it would have had a severe impact. I mean, the root growth probably wouldn't have gotten down, like you said, with it growing initially, roots were able to establish themselves. Excuse me. If it was there initially, the roots might not have hardly gotten past the soil surface. So that would have really affected some issues. It would really probably push the plants over a lot easier because that root growth wasn't down. It was just flattened out. So like you said, with it actually being established, it was already starting to grow down. We were looking more at sidewall compaction than we were actual overall compaction. So.
Probably brace roots more.
Yep.
Would your deep ripping take out any combine tracks and that, do you think?
That's kind of the idea behind it. That's what our hopes are. That's why we go ahead and do deep rip in the fall application. With that particular field, it's just a combine. We don't allow auger carts or anything like that to add on extra compaction. The deep ripper the intent is to get rid of that combine compaction that was actually out there so that we're not looking at any other compaction issues.
In your conclusion, you mentioned that in North America, the recommendation now is not any post trips across the field after planting.
For this study.
How comfortable do you feel based on one set of data in Illinois
I think we're gonna try and do it at a couple other locations. Like I said, like you said, it's just one location. It's 2 years, but it's one location. So there is talk of doing it in other locations, just to see if it holds true in different soil types and that kind of stuff. But for our location particularly, it's not gonna be. We're not gonna do anything. So
So what type of soil did you have on this side?
sable, silty, clay loam.
Clay loam?
Yep.
If you were to do this again, what would you do differently, or would you do anything differently?
I think I would stick with the 2014 experimental design, the way the field was laid out. I'd probably add in an extra treatment for a dry application, both dry or both empty and wet. That way we could see if full sprayer going through there was going to affect anything differently than what we saw everywhere else. Outside of that, I think I'd pretty much keep it the same. I'd like to do it again this year, but I don't know if the resources are going to be available to run the study for a third year at our location.
If he doesn't pass today, he might have to.
True. Yes.
You could use the same experimental setup for analysis that you could do a drone application of herbicides and see if that made a difference in half all the way.
Very well could. Could be, that's what we were talking about, aerial application, just to see if, it's not really the herbicide necessarily that's affecting it, it's the compaction itself. So we could definitely run all kinds of different experiments, but for this one it was just on the equipment.